The observable universe stretches 93 billion light-years in diameter, a number so vast it completely shatters the human capacity for comprehension. Yet everything we see, every star, every galaxy, represents less than 5% of what actually exists. The rest of the cosmos lies shrouded in an absolute darkness we cannot penetrate, not because our technology is inadequate, but because the very fabric of spacetime has stretched beyond our visible horizon. Light from those regions will never, ever reach us. Galaxies beyond the observable edge are fleeing from us at velocities exceeding the speed of light, driven by the relentless acceleration of dark energy. This isn't a violation of physics, it's the universe expanding so rapidly that some parts are permanently lost to us forever. At the heart of every major galaxy lurks a monster known as a supermassive black hole, a region where gravity becomes so infinitely intense that it tears the very structure of spacetime. Cross its boundary, the event horizon, and your atomic structure will be stretched into a stream of particles. As you spiral toward the singularity, an external observer would witness you slow down, freeze at the edge, and eventually fade into nothingness, your image trapped eternally on the surface. For you, however, time continues normally until you are completely ripped apart. Inside that point of infinite density known as the singularity, all the known laws of physics, every equation we hold sacred, completely evaporate into meaninglessness. It is a realm where space and time cease to function, a place where our universe came from. Our galaxy, the Milky Way, orbits a beast 4 million times heavier than our Sun. Known as Sagittarius A, this dormant giant sits silently in the center, and it has been watching over the Earth since before the first dinosaur ever drew breath. Stepping back, we realize that normal matter, the stuff of planets, stars, and our own bodies, constitutes a mere 4% of the universe's total budget. The rest is an invisible enigma classified as dark matter and dark energy. We know dark matter exists not because we can see it, but because we observe its gravitational grip, bending the light from distant galaxies and holding clusters together. It acts as the scaffolding upon which all visible structures are built. In 2016, humanity witnessed the collision of two black holes over 1 billion years ago, a cataclysm that released more energy in a fraction of a second than all the stars in the observable universe combined. We detected it through ripples in spacetime. These ripples stretched and compressed Earth itself, like a stone dropped into a cosmic pond, confirming Einstein's predictions. The universe is not a silent static void, it is a violent ocean of warping reality. Turning our gaze homeward, our sun is a middle-aged star nearing the halfway point of its life cycle. In roughly 5 billion years, it will exhaust its hydrogen fuel and begin its terminal expansion into a red giant. As it swells, it will engulf Mercury, Venus, and quite possibly Earth itself. If our planet survives the inferno, it will be reduced to a scorched, molten cinder, erasing every trace of human existence in a blink of the cosmic eye. However, the destruction of our planet is just a footnote compared to the potential fates awaiting the cosmos. The leading contender is the Big Rip, where accelerating dark energy tears galaxies, then stars, and finally atoms apart. The Big Rip wouldn't end with a cosmic explosion, but with a silent, relentless undoing of reality itself, stretching matter so thin that the entire universe dissolves into unconnected elementary particles. Alternatively, the universe may face heat death, a slow descent into total thermal equilibrium where every star extinguishes, every black hole evaporates, and all motion ceases permanently. It is an endless, unchanging darkness. The timeline for heat death is so unimaginably long that the number of years surpasses the total atoms in the observable universe. Yet mathematically, it remains the most likely outcome for our reality. Moving to the quantum realm, physicists entertain the terrifying idea of the Boltzmann brain. Over infinite time, random particles could spontaneously assemble into a conscious brain floating in the void, hallucinating a reality we call existence. Statistically, self-aware brains appearing from chaos are more likely to occur than the fine-tuned universe we observe. This implies we might be living inside the fleeting dream of a random fluctuation rather than a stable cosmos. Consider the Fermi Paradox. With billions of habitable planets in our galaxy alone, where are all the intelligent aliens? The silence is deafening, and it suggests that advanced civilizations inevitably destroy themselves before reaching the stars. This brings us to the Great Filter Hypothesis, a terrifying barrier that nearly all life fails to cross. We may be past it, or worse, it might be lurking in our future, waiting to wipe us out precisely when we reach technological maturity. On a sensory level, we perceive only a tiny sliver of the electromagnetic spectrum. The universe is filled with gamma rays, X rays, and radio waves that paint a chaotic picture of the cosmos, but our eyes are blind to the violence occurring right around us. Our sense of time is a neurological illusion. Physics tells us that past, present, and future exist simultaneously in a block universe. The death of your loved ones, your own eventual expiration, is already fixed in the fabric of spacetime. In the end, we are a fragile dust mote floating on an infinite, silent, and utterly indifferent ocean of emptiness. We are temporary arrangements of atoms that have the audacity to feel important, while the universe simply remains dark and silent.